Nathaniel? 1 through 14. All right. Also, Nathaniel, which ones did we do in class before we started? Anybody remember? We did number 1, right? Did we do number 2? I don't remember if we did or not. Did we?
We did 1 through 6. Yeah, in class. And we did 8 through 10.
So we went. Okay, so let's review a couple just to refresh our memories. So number 2. Let's just review. So let me call on Izzy. Will you help me with number 2? So it's 4 times 5 and an 8. Okay, so there's 2 things I can do times 4, right? So what are they?
4 times 5.
Plus, that's right. 4 times. Yeah. Okay. So 4 times 1/8 is a half. Okay. So that's worth a half. And this is 20. So 20 and a half. Okay, let's do the old-fashioned algorithm, which would be 41/8. Did I do that right? What's 41 times 4? Did you say 164? And 164, 8 goes into that 20 times with 4 left over. So it does. Same thing, right? So again, remember, distributive property is when I'm distributing multiplication through more than one part of factors, where I'm refactoring to get to the same result. Now you're going, well, why would I do that with something like that? Well, first of all, to understand why it works. But the second reason you wouldn't, so why would you do that? You wouldn't if you were just using the regular algorithm, because remember, an algorithm is the more efficient, which means the faster way to do something, but the algorithm doesn't explore your understanding of what the concept is. But why is it we need to know distributive property? Because when we're doing algebra where there are going to be variables involved, that's going to be the only way we're going to be able to solve things, by factoring it with distributive property. That's why we're practicing with just numbers right now. Okay, Fred, would you help me with number 4? Let's review that. So number 4, number 1, 2, and 3, I had a problem that I broke it down with distributive property, right? And now in number 4, I've got the letters involved, right? So I'm saying that 8 times x plus 7, I need to know how to get the answer to that. Now, here's what we need to know, Fred. So we've got 8 sets of stuff, right? So 8 people are getting $7 and a mystery envelope of cash, right? We don't know what the mystery envelope of cash is. That's okay, right? We don't know what it is, but that's okay. So how do we break that down using distributive property?
Do like 8 times x.
8x, which is 8 times x,
And then
plus 7, right? Plus 7. That's the common mistake that everybody makes.
8 times 7.
Yeah, 8 times 7. It's plus 8 times 7, which is 56. Right? So I got to distribute the multiplication through both parts. Here's what that would be like saying 8 people got a mystery envelope, but only one of them got the $7. If I don't put the 7, sounds good. You need like other paper towel that's more absorbent. Is it a big store? Okay. All right. So yeah. As I call your name, will you please explain? Did we do number 7?
Yes.
No.
Oh, we can do it.
All right. As I call your name, will you tell us what the answer should be according to your homework? All right. Number 5, Josiah. Okay, so what's 11 times 6? 66 plus 6x. So you got 66 plus 6x. All right. Number 6. Ashley, what'd you get for number 6? So I'm going to multiply 8 times x, and what I get? 8x. I don't know if you were here when we did this or not. You already know. No, you were here. Okay, and then 8 times 1, which is 8, right? Natalia, what would be the common mistake that a kid might do on number 6 when they did distributed property there?
They might do 8x.
Right, that's the big mistake that kids do all the time. They forget to distribute the 8 times the second part. It's got to go through the whole thing. All right, Izzy, number 8.
Yeah.
So I need to factor out 8 plus 16. So let me write it down. 8 plus 16. So knowing my math facts here is important so that I know what factors work with both. What factors work with both? There's 3 of them. What are they?
There's 2.
So there's 1 and there's 2.
1, 2.
What else? And? So there are actually, every factor of 8 also is a factor of 16 because 8 times 2 is 16, right? All right, so should I use the 1, the 2, the 4, or the 8 to factor this out? What do you say?
I say.
So let me say this to you. Any of them would work, except if you're taking a test, they're going to ask you to factor it in simplest terms. So in that case, you got to use which factor? No, that sounds like these factors. What? 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 Did you use 8? Okay, so 8 goes into 8 how many times? 1. So 1 plus 2, and it's times the 8, right? All right. Number 9, Melis. Checking your work. Even if we did this in class, we're doing it again. We had people out. So, Melis, we know 2 works, right? Just 4? No. Because 4 doesn't go to 54. Right? Okay, so it's got to be 2. Any other factors? 6? Yeah. Right? Isn't 6 times 9 54? Isn't 9? Isn't 6 times 9 54? And isn't 6 times 4 24? So should I use 6? Okay. So I'm going to factor 6 through both parts. Now, if you're not good with these, please focus on these because you're going to have a quiz on them tomorrow where you're going to have to factor like this just to practice. Okay, so please, if you're not clear on how to do these, please watch carefully and ask questions. Okay, so 6 goes into 54 how many times?
9.
9. And 6 goes into 24 how many times?
4.
Okay. Question. Could I solve both of those and know that they equal each other? Okay, what's 54 and 24? Did you say 78?
Yeah.
Right, because you went 70 and 8, right? That's it. Okay, what's 9 plus 4? What's 13 times 6? 78. Right? All right. Help me with number 10. Angelo. Number 10. What's that? That's exactly right. He factored out 9 And it's 7 plus 9? Yeah. So there's a 9 in both places? Why is there a 9 in both of these places? Because 9 times 9 is 8. Alright? So yeah, that's right. Help me out with number 11, Madeline. So you factored 11, and then what's over in here? X plus 5. Yeah. Okay. So let's look. 11x, 55, and there's what I had, right? So that one just did it the other way back, right? Chloe, will you help me with number 12?
Yeah.
Thank you. It says 32 plus 16x.
I did 2 in parentheses, 32, or wait, never mind. I did this one.
Because it's 16, isn't it?
Yeah.
See, great that you caught that there's a bigger factor, right? Now, was the other factor you just did a factor that works? But is it in simplest form? No, so now you're going to get it in simplest form, right?
Yeah.
So what you going to get?
So 2 in parentheses, 16 plus 8.
Like that? You sure? No, do you see what I wrote?
Yeah.
8x?
I did 2 in parentheses, 16 plus 8x.
Okay, you did 2 in parentheses 16 plus 8x, but is it in simplest form? No, because don't all those break down more? All right, so not simplest form. Okay, I need you to look it up. Look at the screen, please. Okay, so Chloe, doesn't 16 itself go into 16 and 32? Okay, so if I factor out 16 from both, that's going to be 2 plus x. And 16 out here, right? Let's check, okay? Chloe, what's 16 times 2?
32.
What's 16 times x?
16.
Alright? Okay, let's jot that one in our notes. Because people are not, a bunch of people probably missed that only because of the factor. Because you probably did what Chloe did, because you didn't catch that 16 is the biggest factor. So everybody go ahead and write that one in your notes. Even if you got it right, or if you write it in your notes. Please. Okay, as I said, in the morning, we will take a quiz on factoring. Okay, we're going to work through number 14 together. But before we do that, finish writing number 12 in your notes. And I want you to turn and talk with the person beside you, and then Chloe and Courtney if you'll talk. That way everybody has a partner. All right, if you will turn and talk about number 14, discuss what you got for 14A, and discuss what you got for 14B. All right? Has everybody copied number 12 already? Very good on that one. Okay. Will you turn and talk with the person beside you, not across from you, beside you? And will you talk about what you got for 14A and B? Okay, go ahead and discuss what you got on 14A and 14B.
No, he
Yeah,
gets all
turn and
the
talk.
like
Number 14. All right. So is the first question you had to ask yourself is what's the problem that I had to do? So how did I figure out what on that menu I was supposed to use? How would I figure that out? Because it didn't say. So how would I figure it out? How would I figure it out? What's the first clue of what I got to do? Yeah, Betty? Okay, the question was, from the second frame, I wonder which is cheaper. But then the next question is, cheaper which things? Because there's like adult prices, kid prices, movie pass prices, Friday night prices. Okay, the next question is, I need to compare what? What is it I need to compare? Well, who's asking the question? A kid? It's a kid, right? So am I examining the kid prices, not the adult prices? Is that correct? Shouldn't I be examining the kid prices, not the adult prices? All right, so it says that the youth price is $7.50 regularly, right? Okay. And it says that the Friday night youth price, well, what? Is what? For everybody is $7, right? Right? So that would cover Friday, right? Alright? So that could be the case. Or is the case that they're comparing that it's Friday night and they're deciding, is it going to be better to use the movie pass or just the Friday night all ages? Because it looks like they got a special on Friday nights, right? So you could be a grown-up on Friday night and you go for $7, regardless if you have the individual movie pass or not, right? So that's comparing that $7. So $7 plus $7.50. How many people are going? We don't know. It's just eggs, right?
It's individual, so.
So who got that? So let's say you didn't get that. Will you go ahead and write that in your number 14A? If you didn't get that. Now, hopefully they would never give you one on a test. That's kind of, you have to really look at the graphic novel frames to catch the question, because I could see how that could easily, you get a different number because you misinterpreted the graphic. I had to look at it a couple times myself to make sure. Then I had to check and see if that's what they intended. All right. So some people paid $7.50 and some paid $7. No. What's that mean then? It says we want to find the cost of a certain number of tickets for admission and a movie pass on family night. So movie pass is $7 and the ticket is $7.50, or vice versa. Actually, vice versa, right? So there confirms what we got to do. So it is on family night, and it's 7 plus $7.50. Let's say it was 20 people that went. It would be $7.50 plus 7, which is $14.50 times 20 people, right? Right. Correct? So let's say it's 10 people. It's $14.50. That's $140 and right. Excuse me, $145 if it's 10 people. Yeah. All right. Well, we don't know. What if I need to know how much it is for the movie pass for the 10 people, but also separately how much it is for 10 people for the actual ticket? Then that's where distributed property would come into play. So how would distributed property look for this? Okay, what's that? Yep. X times 750. And then what's this? X times 7. Now, are you normally going to see it with the X outside the parentheses? Sometimes. You're going to more of the time see it inside, but it still works the same way, right? All right. Part B. In Part B, it says, is it less expensive to pay regular admission with the movie pass or to go on family night? So is it cheaper to go on family night or to pay movie pass plus the admission? Fred? Cheaper to do movie pass or go on family night?
It's cheaper to go on regular, not family. Because family is 50 cents more than it needs to be. So.
Okay, anybody disagree or agree? Betty? Okay, why?
Well, it's $7.
Okay, so admission with movie pass is $13.50 for kids, $18.50 for adults. But on family night, it's $14.50 for both, right? So is it kind of actually mixed bag? It's cheaper on family night for adults, but it's cheaper for kids on regular night. So that's actually. So it's actually half and half. It's cheaper for adults on family night, on Friday night, family night, but it's cheaper for kids on regular. Right. So it's actually a half and half answer on that. It's not cheaper for both on either one. It's cheaper for one in one way and one for the other. Yeah.
It says youth, not regular.
So then on youth, it's cheaper on regular day, like Fred said, right? But if you're talking about adults, it's cheaper on family night, right? Yeah. Yep, correct. All right. Let's look on page 493. Okay, 493. We'll work on it. 493, 494. All right. So let's talk about an algebra tile, okay? So I'm going to give you an expression. So if you'll write this in your notes, we're going to practice these in class later this week, but we're going to talk about them first. All right? Okay, so will you jot down in your notes this algebraic expression? Zamir, will you remind me why that is an algebraic expression? It's an expression because there's no equal sign and no balanced, quote, answer or other set of things that balance on the other side. That's first. Why is it an algebraic expression? Because it has something in it that's unknown. It's called a variable, which means it varies from problem to problem. So it's an algebraic expression. Tell me, what is different about that algebraic expression from the ones we've been doing? Kylie, what's different about that expression versus the ones we've seen up until now?
It has more than one variable.
Okay. So here's my next question. Does it have more than one variable or just variables that aren't put together? I know what you mean.
Yeah, that one's put together.
Yeah, that's what you meant. Okay, we can't say there's more than one variable. Why not? Because all the variables are x's, so they're all the same value. So the mystery envelope here, same as these mystery envelopes, correct? Now, it would be two variables if there was a mystery envelope for x and there was another mystery envelope named y. That means there's two variables. This is not two variables. It's just one variable that's not simplified. Write that down. What's different about this expression is it is unsimplified. Write this down in your notes. You don't even have your notes open. That's the difference. This expression is not simplified. This expression does not have two variables. You're going, well, there's 2x and there's a 3x. That's the same variables. They're just not 5x. Shouldn't they just be 5x? Shouldn't it just be 5x? So write down, this is an unsimplified algebraic expression. So on tomorrow's quiz, I'm going to say that. What does that mean? I'm going to give you that on the quiz. I'm going to say, what is this? You're going to say it's an unsimplified algebraic expression. I'm going to say, why? You're going to say, well, it's an expression because there's not an equal sign. It's an algebraic expression because it's got variables. It's unsimplified because the variables are not all together. Right? So in other words, has anybody ever had change in their hand and they don't have all the nickels together and all the dimes together and all the quarters together? If you put them all in stacks together, that's simpler looking, right? You don't call it that, but it is, right? You kind of simplified to see what money you got. Isn't that how you figure it out a lot of times? Put all your quarters together. Like if you're at the ball game and you're the one doing the concessions or whatever, that's what you do, yes. Like a copy of it?
Yeah.
Let me look. No, not that. Nope, not that. Looks like I'm out. Let me look here. Wait, here. Where'd he go? Take that to Mr. Johnson. He's scrammed. All right. And then you would say, again, it's unsimplified because the variables all need to be grouped together. There used to be this awesome app called Algebra Touch where you could practice simplifying expressions. You literally just drag your x's together and it would go beep and show you it was correct. Like it would say like 5x plus 2 plus 3x plus 9 plus 5x plus 1. And you put all the numbers together and all the variables together and it would tell you the result of the simplified version of that. But it went away. All right, so that would be an unsimplified algebraic expression. So if you're smart, you're writing that in your notes so that you can look over that tonight so that you get that correct on the quiz. So all I need to do is I need to group like terms. So write this down. To simplify, group like terms. Now, we learned what a term is. That means any numbers, also called constants, right? Do we have a constant in this? Yeah, 4. 4 is 4 is 4 is 4, right? Doesn't matter if it's raining and it's Tuesday, it's still a 4. Doesn't matter if it's freezing cold and it's Tuesday, it's still a 4. Don't care if it's hot in July, it's still a 4. Now, we also have 2 x's and 3 x's. We need to put all those x's together, and that's 5 x's. All right? Here's what that would all look like as algebra tiles. Agreed? You know, I can't tell what that is. That's 2 x's, then that's 4 1's, and then that's 3 x's. Now, if I put those on a platform or a table, you go, oh, well, let me just put all these x's together here, and we put these 4 together and count them up. So that's 5 of the x's and 4 of the 1's, right? So this would all simplify to 5x plus 4. Now, does that factor? I don't know what you mean. Can I factor that with distributive property? The answer is no, because they don't have a common factor other than 1, which would still just be that, correct? There's no common factor with 5 and 4, agree? Besides, obviously, 1, and that doesn't change it. So that's in simplest form. All right, let's do number 1 on page 494. We're going to do these together. So number 1, I'm going to draw a little mat here, just like it's in your book. And I'm going to give you this x plus 4x plus x. Question, is that an algebraic expression? Courtney. Yes. Does it have both, Courtney, does it have both variables and constants? No. She said no. It only has constants? No. It only has variables? Yes, she's lying. Because it's got an x, it's got 4 more x's, it's got another x. We know since kindergarten, 4 plus 1 is 6. Right? Okay, mystery envelope. 4 more mystery envelopes. Mystery envelope. Went to the mailbox. Grandma sent me a mystery envelope. She's just going to keep sending them. Went to the mailbox on Thursday. There were 4 sitting in there. Went back on Friday, another one. How many mystery envelopes have come from Grandma? 6. They all have the same thing in them. So to simplify that, I'm going to have x plus 4 x's plus another x. 6x. Write this in your book. So again, I got an x, I got 4 more x's, and I got another x. All those combine to 6x. It's not hard. It's not hard. Not hard. All right, number 2, Fallon. You're going to walk us through number 2, okay? Do you mind? Thank you. All right, so Fallon, here's the first thing I want to do. I want to draw a box because you got one in your book and I need one to mirror yours. All right? Okay. All right. So I got, Fallon, I got 4x. I got 7. I got 2x. Do you agree, Fallon? Now, my question to anybody is this, first of all. Is there addition involved in this algebraic expression? The answer is duh, because there's a plus and a plus. Next question. Is there multiplication in this algebraic expression? Natalia says yes. She is correct. But Natalia, I do not see any multiplication symbols. But you are correct. How? Yep. This is multiplication. This is multiplication. Okay? Here's the thing. When I'm using the algebra tiles, I'm breaking that repeated multiplication down into addition. Sorry, I'm breaking the multiplication down into repeated addition when I use the tiles. Okay? So this would be x plus x plus x plus x, correct? 4x, all right? So in the little box, I need you to draw an x, an x, an x, an x, okay? Are there any more x's? Yeah, okay. That took care of these 4, didn't it? But there's 2 more. I need to like terms together. I need to group like terms together. So I need these x's together. Let's put those 2 with it, okay? So I'm going to put 2 more. So this represents that. Here's 2 more. X, X. Here are those 2. There's also, what else? Foul. What else is there on there? 7 ones, right? So there are 7 ones. So here is 1, 2, 3, 4, 5, 6, 7. So in your mat, you should have that. In your mat, you should have that. Okay, number 3. We're going to do all of this together. Kimani, will you help me with number 3, please? So I'm going to draw the box. Okay, what is the expression, Kimani, in number 3?
Expression.
Is it this?
Yes.
All right. So, Kimani, how many of these are there?
There are 2 of them.
Okay. Here's what's in my box. 2x, right?
Yes.
And how many 1s are there?
2.
There's 2, but it's what?
2.
2 sets of it, right?
2 sets.
There are 2 sets of 2, correct?
Yes.
So it's 2x plus 4. Ashley, look. It's 2x plus 4. 2x, 4 constants, okay? So this variable, this constant, this coefficient, also a variable, constant. What do you call both of these things without the plus? Terms, right? Because terms can be constants or coefficients or variables, right? Try number 4 by yourself. It says, determine if the expression x plus 1 plus 3x and 4x plus 1 would be the same. Would they be the same? Michaela, number 4, did you decide that they are the same? Yes? Liam, do you agree that they are the same, equivalent? Okay. Josie, do you agree that the 2 things in number 4 are equal? You say no. Why do you say no? I got x plus 1 plus 3x, and I got 4x plus 1. They are equivalent. Because if I group like terms, when I group like terms, that would mean when I group all the x's together, I've got x plus 3x, that's 4x, and I've got 1, right? So x plus 3x plus 1 is the same as 4x plus 1, right? So they are equivalent. They are the same. On 495, fill in the blank where it says label the graphic organizer. So here are the 3 words I need in there. I need the word terms. I need the word like terms. I need the word constant. So when I'm referring to the 4n and the 2n and the 9, that's my what? When I'm referring to the 4n and the 2n, those are what? And when I refer to just the 9, that's a what? So fill in the 3 boxes on page 495 in the little graphic organizer section. All right, so James, what did you say this is?
I said that was constant.
You are correct. That's a constant. Okay? That is a constant. All right. Graham, what did you say this are all considered?
I said 3 terms.
That is, those are all terms, and there are 3 of them. Terms mean constants or variables. All right? Now, if it were simplified, would there still be 3 terms? If that was simplified, how many terms would there be now? Okay, listen. If I simplify that, are there still 3 terms? 2 terms. Because I put all the ends together, right? So I have that as 1 term, and the 9 would be another term, right? Fred, what do I call these 2 terms?
Variable or coefficient.
Okay, but they're both the same thing, so they are both coefficients, but what are they called when they're the same kind of variable? They're alike, aren't they? Yeah, it's called a like term. Okay, write that down. So you call them terms if they're the same letter, they're like terms. So what if there'd been another term, a 2? What would I call the 9 and the 2 then? They would be like terms. So in other words, I always gather all my variables that are the same kind of variable. Then I gather all my constants together because they're considered like terms. Okay, if you haven't got that, you want to make a note of that. That's super important to remember. Please make a note of that. All right, 496. We're going to do the got it, ABC. On 496, we're going to do the got it section, A, B, and C. And if you will send me a picture of your answer for A, B, and C on page 496. So I'm talking about a 496, A, B, and C. order of operations. Again, take a picture of that section that's called Got It with your answers and send that to me. Raise your hand if you've not sent me your answers. Okay, Fred. Okay, just go ahead and take your picture and I'll have you text me. Please record your picture. And I'll look at it. All right. Anybody has not sent it? Anybody else? Anybody else that the Wi-Fi wouldn't let them send? So I need to come and look. So I still want you to take the picture, and I can get it from you later. But I need to verify what you took a picture of before I go again. Is that everybody? All right. Nathaniel. Let's start with this one. Okay. Order of operations says that inside here I've got what? Right, that's what I'm saying. What's inside there?
3x.
Okay, so that's 3x. Okay? We agree that's 3x. Times, not plus, times 11. And that becomes 11 sets of 3x, which is, yeah, 33x. Who got 33x? Now, with distributive property of work, what's 11 times x? 11x, 3 times 11x is still 33x, right? All right, Mason, what about B? These are pluses. So what do you get? And that becomes, yes, that one is 3x. Okay, I want you to pay attention. This is multiply. These are add. That's why this is 3x. X plus x plus x is 3x. This is 3 times x, or 3x coefficient, times 11 sets of that. So it's 3x, 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 33x. Right? So that's saying I got 33 mystery envelopes. Here I got 3 mystery envelopes. There's a difference with pluses and timeses. Right? Don't know. Permita. C. First of all, Permita, how many terms are in C? How many terms? 3. Are there any like terms? Yes. There are like terms of 7x and x. So 7x and x become 8x plus 8. Correct? Now, can you go a step further? Could I factor that? Can I factor this? Could I do this? Yes. So look, what she just did, okay, let me walk you through that. She took an unsimplified expression, she simplified it. Okay, if I look again, look. Unsimplified, simplified. Combine your like terms. Ashley, look. Combine your like terms. X and x, 8x, 8. Now, I can factor it out because it has a common factor of 8, right? 8 goes in 8x, 8 goes in 8. So it's 8 times x plus 1. Now, let's prove that all that stuff is the same. I'm going to tell you right now, x equals 2. So let's figure all this out. Okay, if you'll write this in your notes, I'm telling you that x is worth 2. So I've got 7x plus 8 plus x. So my grandma is sending me mystery envelopes with $2 on each one. Okay? So this, we're writing this in our notes. This right here. Okay, x is worth 2. Alright? We're going to prove all this stuff is the same. Alright, so this is unsimplified. So everything in this box should be in your notes. This is unsimplified. It has 3 terms. It has a set of like terms. There are 3 terms. There's a set of like terms. It is unsimplified. I'm now going to simplify it. Here it is simplified. 8x plus 8. Now it's simplified. Now I'm going to factor it. I'm now going to factor it. Factor it means exactly what it sounds like it means. It means find a common factor and break it down. Now I'm going to factor it. Here it is factored. 8 goes into x, x times. 8 goes into 8 one time. There it is factored. Here it is unsimplified. It's got 3 terms. 2 of them are like terms. That means they can go together to simplify to 8x plus 8. Now that one will factor because 8x can be broken down by 8. 8 can be broken down by 8. 8 times x plus 1. Now, let's plug in 2 for all the x's and see what happens. Alright? 7x plus 8 plus x. 7 times 2 plus 8 plus 2. 14 plus 8 plus 2 is $24. Okay? Which you can't see. All right? Let's plug it in here. Okay? plug it in there. 8x plus 8. 8 times 2 plus 8. 8 times 2 is 16. 16 plus 8 is 24. Bingo. Now let's do the factored version. 8. 2 plus 1. What's 2 plus 1? 3. What's 3 times 8? 24. That's how you know all of that is correct. Because if you put in a value for your variable, they should all equal the same amount of money. Lee, you writing this down? Got this down. Okay, let me walk through it one more time with you. Okay, so 7x plus 8 plus x is an unsimplified expression. It's an algebraic expression, right? 3 terms. These two are like terms, therefore they can go together into 8x plus 8. That's the simplified version. Here I factored it out because 8 goes into both 8x and 8. So it becomes 8 in parentheses, x plus 1. Then I'm going to plug in 2 for all the x's. Up here I got 14 plus 8 plus 2, that's 24. When I do it here, I got 16 plus 8, that's 24. When I do it here, I got 3 times 8, that's 24. All right, for homework. On page 499. You've done everything else already. On 499, we're going to do numbers 1 through 8. 1 through 8. 1 through 8. Okay, when you finish with your math, if you will go ahead and reach in the basket and take out the article of the week on ancient Greece. And if you will, so let's go ahead and do that first. Take out the ancient Greece article and put your name on it. You'll just lay these things on his desk. And I'll... Okay, so if everybody will take out your ancient Greece article of the week. Come on and grab yours. Please. All right. And if you will pass around the science world, that will be on later this week. You'll put your science world in your magazine folder. Next thing, if you'll reach in and get the time for kids, that's tonight's tech task. Because what I was about to say was, when you finish math, go ahead and work on your time for kids tech task. Then there's your financial literacy and the TFK that's in there. And then if you will stop there, leave the rest in there. I want you to have the TFK now, so you put the scholastic news away, the science world away, put the ancient Greece article away, finish your math first, then work on your tech task for tonight, which is the TFK questions. That's a that?
a lot of controversy.
They interviewed. Did anybody see the Family Feud thing in Canada where that lady, they said, what's Popeye's favorite food? She went, chicken. And they're like, no, spinach. Because it's talking about Popeye the cartoon. Nobody saw that? It was on all kinds of, like, those bloopers of the week things. Yeah, she was all like dancing, thinking she got it because that was to win the game on Family Feud. It was in Canada. It wasn't Steve Harvey's Family Feud. It was some random Canada version. But she was doing all that, and then they're like, and the other guy went, spinach? You know, the cartoon, not the story.
Yeah.
So then Popeyes, the restaurant, gave her like $10,000 in Popeyes chicken sandwiches.
I don't believe it.
Well, yeah, because you kind of like advertise them right there.
Alright, you have 20 minutes, no, 15 minutes to finish your math first, 1 through 8, then work on your TFK. After you come back from related studies, we will do Quizlet Live to practice before the spelling vocab test. And for me, if you'll pause. Good job, everybody.
What's up, dude? Bye bye.